I wanted to discuss the magic square project briefly and how you would walk the diagonals of a two-dimensional array, which you would have to do for the magic square project. Now, a magic square is a numeric two-dimensional array where if we add up all the rows individually and then all the columns individually and then the two diagonals, if they all add to the same number, then we know we have a magic square. And it can be like a 4 by 4 or a 5 by 5 or a 3 by 3 two-dimensional array. But as long as everything adds up to the same number, we have a magic square. If any of those sums are different, we do not have a magic square. So to begin with, I've declared a two-dimensional array. Similar to when you declare a one-dimensional array, you put the empty brackets after the data type. Well, here you put two sets, and so that of course is going to indicate it is a two-dimensional array with both rows and columns. And then after you do your equals new int, here you come in, and if you want a 4 by 4, you want 4 rows and 4 columns, you put 4 here. I'm doing a 5 by 5, 5 rows, 5 columns. The first number is always the number of rows. The second is always the number of columns. And then I'm going to let my two-dimensional array get populated with the random numbers, meaning the odds of me getting a magic square are pretty slim. You can certainly hard code the values in there as well. But to save time, I just randomly had numbers fill in. So in order to get values into a two-dimensional array, in the case where I'm using random numbers, or if you were using scanner and having the user enter each number, I would do a nested for loop. Now, if you're going to hard code the values by hand, you don't even need a loop at all for that. But if you're going to have any type of dynamic way of populating the array, whether through scanner or through random numbers, in order to populate it, you need a set of nested for loops. So you have the outer for loop and the inner loop. Now I always do my outer loop as the row and my inner as the column. And what happens is I go to row 0 and this loop is executed one time, and then the inner loop in this case is going to run 5 times, and I'm going to go put the numbers, for example, following this magic square that got generated for me. The first time the row loop executes, row is 0, then it goes in and runs the internal nested for loop for columns 5 times, and it goes across and it puts 4 1 4 1 4. Then it's done with the inner row. It comes back, row becomes a 1. Now the inner column loop is going to start again at column 0 and go across and populate 5 2 4 4 1. Then the inner loop ends, row becomes a 2. The inner loop runs 4 times again, and I get 2 2 2 3 3 and so on until the array is filled up. So I'm literally going across. I'm going to row 0 and then I'm putting each column in. Then I'm going to row 1 and putting each column in, and so on. Now I did the same thing to print it out just so we could see the values in it. I again went row with my outer loop, column with my inner loop, so I could print it out in the correct order. It starts at row 0 and it prints out 4 1 4 1 4. Then it goes to row 1. The inner loop runs and prints out 5 2 4 4 1, and so on. Now I used a print statement, and of course I put a space after each number for readability. And so what happens is as the inner loop runs, it puts all the numbers on the same line followed by a space. So it puts 4 space, 1 space, 4 space, 1 space, 4 space. There's a space at the end even though we really don't see it. And then it comes back and it goes to the next row and prints out 5 space, 2 space, 4 space, 4 space, 1 space. Now in order to force the carriage return so I get the grid look in my output, after the inner loop runs, before it cycles back and goes to row 1 and row 2 and row 3, etc., I force a carriage return with a print line statement. So notice I have just a print in the inner for loop, but a print line for each time it loops again with the outer loop. So it forces a new row. So now I want to check and see if it's a magic square. And there are several ways I can check. The first thing I want to talk about is walking the primary or main diagonal. The primary or main diagonal starts in the upper left and goes to the lower right. So in this case it would be 4, 2, 2, 1, 5. That's the primary. That's just by definition, that's the primary diagonal. And in that case it is also the rule for the primary diagonal that the row number and column numbers are equal. So you'll notice this is 0, 0, the 4, the 2 is 1, 1, this 2 is 2, 2, this one is 3, 3, and this 5 is 4, 4. So it's row 4, column 4. So wherever the column number and the row number are the same, where they're equal, that will constitute your primary diagonal pretty much no matter what the size of your array is. So in order to walk that array or sum up the values, in that diagonal, there's two ways I can do it. I tend to do it the more painful way, which is I use two sets of loops similar to what I used earlier in the code, going down and then checking in the inner loop if the row number and the column number are the same. So when I'm on row 0, column 0, I'm going to grab that number, which is 4 in this case, and accumulate the sum in this diag1 accumulator variable. Now the problem with this is it's very inefficient, because even though I've done 0, 0, it's still going to walk across the row when I've already found my row column number being the same, 0, 0. So there's no other number on the first row I'm going to add in, but this loop is still going to run and double check everything. So I'm wasting time. So a better way to do it is to do something like this. Just because it's a 2D array doesn't mean I always have to use nested for loops. I do to populate it generally and to print it out. But in this case where I'm just going to add up the primary diagonal, I can use one for loop. And notice I can say, similar to the row for loop up here, I'm going to say instead of row, I could have used row here, I'm using diag. If diag equals, when diag equals 0, loop until it is less than 5, so diag is going to go 0, 1, 2, 3, 4, and it's going to bump up by 1 each time, typical for loop. But what I'm doing is, look here, this is kind of slick. Since I'm saying I'm adding up the 0, 0 value, the 1, 1, the 2, 2, the 3, 3, the 4, 4, where the row and column number are equal, this is much more efficient and a better way to do it. Where I have one for loop and I say my diagonal starts out as 0, so get the value in 0, 0 in the magic 2D array, which is 4. Now diag becomes a 1, now get the value at 1, 1, which is the 2, and add it to the value. So this is a better way, a more efficient way to do it. Now the secondary diagonal is the opposite one. It goes from the upper right to the lower left. So in this case it's got 4, 4, 2, 3, 4 in it. Now this one you need a little bit of a formula, and this should work for any two-dimensional array, no matter what size it is. Now here I decided instead of hard coding a 5 that I would leverage off of the length, which has the value 5. If I say magic.length, length says give me the total count of the first dimension of the number of rows, and that's important. If I had 5 rows and 10 columns, length is going to give me back 5. This will always give me back the number of rows, the first dimension. So in this case I've got a 5 by 5 grid, so that works perfectly. So instead of hard coding a 5 here, I'm leveraging off of that, and it will substitute the 5 in there for me. But if I go to a 3 by 3 grid, it would substitute in a 3 for the 3 rows, so I can change the size of my 2D array without having to worry about changing each for loop. So I'm going to say here I want to add the secondary diagonal. Again, I only need one for loop, and I'm going to go from the first row to the second to the third to the fourth. I could have used int row equals 0 here instead of diag. And what I'm going to do for the second diagonal is I always take the value that's in my loop counter, whether it's 0, 1, 2, 3, or 4 in this case, and then I take the total number of rows. So again, I'm going to use magic.length, which is 5. I have 5 rows, and I subtract the value that's in the diagonal, and then I subtract another 1. So when diag is 0, my number is going to be 5 minus 0 minus 1, which is 4. So I'm going to have 0 comma 4, and that's going to give me that rightmost element to add up. Then diag becomes 1. So now this is a 1 for row 1, which is perfect. And this is 5 minus 1 minus 1, which is a 3, which gives me row 1, column 3, which is my 4. So you can either commit to memory the formula, which is what I do. So it's length minus diag, or whatever your loop counter is. If I'd called this row here, it would be minus row. This is the loop counter, minus 1. That will always give you the right column value to walk the secondary diagonal of a 2D array. Some people will just remember it because it's logical and makes sense to them. I personally just had to commit the formula to memory. It's array name and then the loop counter and then length minus loop counter minus 1. And that will always correctly walk the secondary diagonal. Now if you wanted to walk the number of, go column by column or row by row to add up those sums, you don't have to use nested for loops. You can just walk the column with one for loop or the rows with one for loop, similar to how I did the diagonals here. So think about that, and then you would basically have an if statement at the end where you would say, if diag1 equal diag2 and diag2 equal row 1, assuming row 1 is the accumulator for the sum of row 1, and so on. You could do a big gigantic if statement and figure out if these guys are magic squares. There is actually a really good website, and I will try to remember to send you the link, that actually talks about figuring out if something is a magic square. It gives you the better code for the two diagonals here. And it also shows you how to check the sum of each column, creating the sum of each row, so that you can figure out whether or not you have a magic square.